So notice what we have. P of t is an ordered triple. It's not xy, it's x, y, and z. And I don't want to graph all of this. I only want to graph the portion of this that is between 0 and 2 pi. Maybe what we can do is we can open up a table of values and we can get some points from the table. And then we can plot these points in space and then we can connect the dots. So my input column is t. I have 3 outputs which can then be pieced together to give me ordered triples, which I can plot in space and call it a day. Now, what t values should we use? Use values between 0 and 2 pi inclusive. So I want to use 0, and then maybe like all the popular numbers, or many of them at least, pi over 4, maybe like pi over 2, 3 pi over 4, pi, how about 5 pi over 4, and then maybe 3 pi over 2, how about 7 pi over 4, so, and then 2 pi. So I've used quite a few, and then what I'm gonna do is I'm gonna plug 0 in for t, there, and there. So sine of 0 is 0, cosine of 0 is 1, and this column is basically gonna be this. So now I can take these numbers, and I can complete an ordered triple. Now let's do the same for pi over 4. So I have this here, and now let's do the same for the rest of the table. So after some time, you'll have your table completed. Do note that all of these numbers can be turned into decimals, really weird decimals, but all of these can be turned into decimals. And once you've done that, you can actually graph all of these points not on the XY axis, but on the XYZ axis. And the XYZ axis looks something like this, where your X axis looks like this, and then your Y axis looks like that, and then your Z axis looks like this. It goes up and down. And this is the positive X axis, that's the negative. This is the positive Y, this is negative Y, positive Z, negative Z. I am going to assume that you guys have discussed how to plot points in space. 3 dimensions, we call it space. R3, that's called space, X, Y, Z. So if you have not graphed points in space, I do have a couple of videos. Just skim through my channel. You'll find how to plot points in space. But if you were to take, for instance, let me just do at least one of these. 0, 1, 0, X, Y, Z. How do I plot the point 0, 1, 0? So 0 for X means you don't go out this way. That's 0 there. And then go 1 for Y, so I'm going here. And then 0 for Z means you don't move up or down. So this is point, that's actually right there. And that is going to be your start point. What about the end point? Where was the end point at? The end point was at 0, 1, 2 pi. 0, 1, 2 pi. That's where I end. So this was my start, and my end was at 0, 1, 2 pi. Let me confirm that. I already forgot what it said. 0, 1, 2 pi. That's true. So let's plot this point here. So 0 for the X means that I don't move at all along the X axis. I stay there. And then 1 for Y means I move out to the 1 for the Y. And then 2 pi is about 6.28. If you turn this into a decimal, it's about 6.28-ish. And that means that from here, I have to go to 6.28 for Z. Z is up positive, down negative. So 1, 2, let's just say it's up here. Let's say that's 6.28. So from here, I have to elevate myself this much of a gap. So roughly like right there. So that point is where I have to end. Now, for all of these other points here, which can be decimals, you can plot all of these points. How about this one? This one caught my attention. So 0, -1 pi. Let's try that one. 0, -1 pi. Let's see here. So 0 means I don't move at all along the x-axis. -1 means that I move back 1 for the y. And then pi is about 3.14 for the z. So from here, go up about 3.14 spaces, and you'd be right here. So I know that whatever I draw has to start here, and at some point has to connect there and end here. I just need all of these other points to be on this grid to do so. That would take us a long time. So what I'm gonna do is I'm gonna use the graphing calculator online and show you what this would look like. So let's go to that graphing calculator now. So I'm here at GeoGebra, And in box number 1, let me type in the function that we had, parentheses, we had sine of t, comma, cosine of t, comma, t, close parentheses. I'm gonna put a few spaces, then I'll open a curly bracket and I'll type in from 0 less than or equal to t less than or equal to 2 pi, because those were the conditions that we had to be between 0 and 2 pi. And now let me hide this here. And notice that, let me hide the equation so we can see the picture. Notice a few things here. It's a touch screen, so I can just pinch the axes. Notice that this is x, y, and z. So if you decide to use GeoGebra as a graphing device, make sure that you pinch the screen in such a way that your x-axis, see that's negative, it has to be backwards. So let me orient this like that. It should be positive x, negative x, positive y. You can see the little negatives. Negative y, up, positive, down, negative z. And notice that what we have looks a lot like what I had. You see here, I had my start point being right there, and notice that's where it starts. I can even zoom in, check that out. That's pretty cool. And in that random point there, that's like right here somewhere. And in the end point there, it's like up there somewhere. So yes, I had to resort to using a graphing calculator because plotting all of these points just would have taken us too long. But it can be done. And if it is done, that's what this would look like. And if I just pinch the screen, it gives you a 3D view of what the path looks like. So this particular example had these functions in this order. But if you were to flip-flop some of these functions, then the overall strategy would have been the same. Some of these numbers would have been backwards. And then you would apply to these points by hand. But if not, you could rely on a graphing calculator like GeoGebra to help you to see what the path looks like.